I'm the creative director of Big Blue Studios, and today I'm going to talk to you how to reduce game design time by 50% potentially or more. A quick question, how many of you are involved in game design? Okay, and I assume the rest of you are involved with people involved with game design, which is the bigger issue. So, just a quick word about myself. I've been in game design since the 90s. I've gone through pretty much everything from indie pen and paper role-playing games to AAA console and PC titles. Yeah, this is one of the games I worked on. And one thing I've noticed consistently is that a lot of time is wasted in game design for the weirdest reasons. So, let's get started. What are game designers? We all know the answer to this, but for this talk, let's consider game designers being like interpreters. So, game designers are the ones that translate a concept or theoretical idea and tell everyone else on the team what to do in order to get the final product. So, why is time wasted? Or likely where? Well, imagine this. All of us have different experiences. We follow different methodologies, different models. We have different terms, different visions. Making a game, even among the same team, is like creating the Tower of Babel. Also, imagine doing this while working on tools which are not designed for game design. These are currently the most popular tools for game design, unfortunately. Having to communicate with other disciplines which often don't have the time or patience to listen to the game design specifics, and keep the documentation up to date. So, what is the root of all the problems? And now prepare for the next slide that will blow your mind. A character is not a player. Why is that relevant? Because with the exception of mini-games, absolutely all design is character related. Which means we think in terms of, okay, we have these stats, these skills, these combinations, this difficulty. Unfortunately, unless we're all working on the same game, this doesn't do us any good. Instead, what we really want to focus on is the thing that doesn't change, the player. Whatever the game, the player does a set amount of things. We provide input, press buttons, move sticks, move if it's virtual reality, have voice commands, we observe, we make decisions. And here is where the molecular approach tries to make one common language which could be used for all games. So, what's the molecular design? It's a methodology that breaks down game design to the smallest components, which are based on player skills. It then uses them to assemble level design elements and puts them in the game progression, in the game blueprints. I'll show you in a minute what that is. And since it's so clear and obvious, a lot of reports could be done very quickly using this methodology and not wasting time to have daily meetings to explain what you did 2 hours prior. Now, let's do a quick analysis. Some of you may have seen this game at some point. So, yeah, what do we do in this game? Well, we can jump, we can move, and for those more skilled than I, we can throw fireballs. However, there is one problem. It is that, in effect, we can do none of those things. The character can. What we do is pretty much this. Now, let me see if okay. So this is the mechanic of jumping. We assume this is the character, this is the space to the platform, and this is the chasm. So all all the player does as a player is provide input within a certain time frame while trying to execute the action within a certain error tolerance. That's all we do in terms of a player. So in this case, this is a difficult example. We have to react, providing the speed, before we reach this point or we fall down. But on the other hand, because this is the maximum difficulty, we have to jump at this point. Otherwise, we have no error tolerance to continue. Now, movement is pretty much similar. We have a direction which is based on input, and we have to react in a certain amount of time based on the object we want to either approach or get away from. Because if it's an enemy, we have to move away. If it's a bonus, we have to get to it before it disappears. Obvious. And finally, we have throwing, which is providing input for a certain amount of instances. The number of instances means if something has 2 health, we have to hit him twice, which is click twice. So in effect, this is what we as players do. These are all our actual parameters, our player skill-based parameters. So let's arrange them like so. Now already we have about 50% of the game in one instance. So I'm not exaggerating. Using this, you can make the entire game on screen. However, we're missing 2 things. As players, we can strategize and observe. Strategize means we decide where to go based on a number of options provided and a threat-reward ratio. So if it's more beneficial for us to go here, that's what we decide. And this is already, as game designers, we make that decision for the player. The player sees what he sees. We just provide the options so that they can decide. And as observation, it's providing visual input so that players can see or not things that are different on the map. For example, hitting this would create nothing. Hitting this, if you look very closely, there is a slight difference. This is a hidden bonus panel. So this is all and good. And coming from this, the role from the molecular tool, or this is a tool that currently I and Big Blue are developing to create, is to have a table that has absolutely all the player skill parameters. In theory, this is most of them, but this is a work in progress, of course, and a lot of error is concerned. So the idea is, once we have this, we can set a difficulty to each one of these cells. Now, this is an example for time to react. Using these cells and their values, we create molecules. Now, molecules represent everything in a level. And in our game, it could be an enemy, it could be an obstacle, it could be an item, it could be anything. We create our huge bunch of elements and put them in this table. Now, this is our time and spatial distribution of the game, or in other words, the blueprint. So here we have all the elements. Let's say this is an element. We have the mechanics they used, on which level it occurs, and where on the map they are located. So from one look here, you can tell what is the progression, what mechanics are introduced, what elements are introduced, and where they're positioned on the map. In one word, this is your entire game, so you can present it to anyone. What are the benefits of this system? Apart from it being very confusing, because shifting from from character design to player design is a bit of a mess. Well, first main benefit, clarity. Because once you figure out everything that's done so far, it's one universal language that doesn't change. I can explain a game to anyone, anywhere, provided they have the same idea, the same methodology. So that also means that I can take pretty much anyone here, take it in a small room with an entirely new game, and in half a day you will know the game as well as I do, because all the things are universally the same and they're very measurable. So there is no subjective based on this approach. And since everything is measurable, it's great for monitoring, because already in the conception phase you know what your game will be. This entire process to create the entire blueprint of a game could take between a day and 2 weeks based on the complexity of your game. So once you have that, you know where you start, you know where you end, and you know how far you've reached. So you can constantly tell someone, okay, this is the bottleneck, this is where we have to put in more effort, or this is what we have to cut. And another beautiful thing is you don't have to go to meetings to give daily reports to your leads and producers. The tool or even an Excel table could be made to give this on a daily basis, like a change log. We've done this, this has been included, we're having problems here, and also QA can use this in order to see what to test specifically, because again, they know absolutely everything in the game up to the parameter itself. And finally, something dear to all of us, it saves a lot of money in many ways. One, it saves designer time, because roughly this, if you take in consideration how many times you go in meetings to discuss terminology or explain to others in the team what you have to do, this already is about 25% reduction, assuming, well, in my experience, I had 2-hour meetings per day on Assassin's Creed just for terminology. So with this, that is gone. Also, you save a lot of programmer time, because you no longer have to go to the programmer and say, oh, please change this or change that, or can you do this, but I can't exactly explain it. You can have the tool linked to an engine, A engine or D engine. If the engine is not complete, you can go faster. And that saves them a lot of time and a lot of, well, harsh words, let's say. And finally, and my personal favorite, once you have made a game, let's say you have made the best game of 2018, you know what your mechanics you like, you want to use them again. Nowadays, you have to start again and copy what you have done. But here, since you, wrong button, here, since you already done the game, you have the mechanics, you can literally drag them from your old game and put them in your new game, and you have the full mechanic, enemies and obstacles included. So in some cases it could be as easy as doing a quick reskin to have the entire game mechanic in your new product, and you can imagine how much time that saves. Also keep in mind, because in your previous game this has gone through tweaking, you know it's going to work. So with that, I can thank you for your time, and if anyone's interested in a more in-depth talk of this, don't hesitate to get in touch with me any means, anytime. So, thanks.
Cool, thank you very much. We've got a few minutes, so I actually think it'd be quite interesting to go into a bit more detail in some of it. So I come from the school where we use use case analysis.
Yep.
So, you know, UML, to be honest, I'm really rubbish at UML, but the principles of defining an actor, what that actor does, and then how that actor, you know, what is observed by the results of that outcome, which is a really useful way to communicate to developers, because it's essentially how a lot of software development is done anyway. So I think that's like a fraction of what you're kind of describing. So I get that. I get that the actor might be a player. The player presses button X, Y, Z at this particular period in time. The result is X, Y, Z. And then there's a dependency, i.e. what does that system affect? I think that's what you're kind of describing. Is that fair?
Sort of, yeah.
Yeah. So what I'm trying to work out is what extra are you describing with this method? So it feels like you're taking the actor kind of classic UML style approach of working, but then adding components like this character or that enemy?
Okay, so the thing is, I'm going much lower, and this is not an entirely new process. It's based on the rational game design method that Ubisoft used.
Okay.
But the idea is that if we look at everything becomes one parameter, one single skill. So the most common is time to react. You have to provide an input within a certain amount of time.
Yes.
So if any actor or any component could be made by a combination of these skills. Having the mechanic done, it becomes like having a template, and just changing the parameters makes all your enemies or obstacles based on that template. So it's like a much simpler system. It's like creating the periodic table in chemistry to create all the molecules.
I kind of get that, and by the way, I'm being self-indulgent here because I find this fascinating. I'm genuinely interested in understanding the model, but it feels like, again, maybe this is my bias, but it feels like there's a lot more work for a designer to break those pieces down. But there's a payoff at the end, which is you've got a componentized model. Yeah,
great point. It's a two-part answer. Yes, shifting towards getting around to understand this at the first time is a bit difficult. It took me personally 3 years because at the time I was given just the only example I was given was time to react. And I said, okay, can I make a game from this? It took me 3 years to manage to make the simplest game. When I mean simple, I mean really simple, jumping over a thing. But once you go through that period, it saves a lot of time because it focuses designer time exactly on game design. No more making documents, no more second-hand translation, like, oh, I want the character to move inside and do this. Okay, what is this? And what is a character? Character is only a surface image. So in terms of this, there's no difference from a first-person shooter and a hack-and-slash melee game. You both move something to a point in the screen and press a button. In some cases, it's a crosshair, in other, it's the character, and you swash. So once you get around this problem, it becomes much, much easier because you only focus on what you want the player to achieve. And then art and the other team, mostly art, decides what the wrapper would be. Like, if this is a racing game, or if this is a first-person shooter game, or any hybrid of everything mentioned already. So does that answer or make things complicated?
Well, it kind of makes me think of more, and I again, please, anyone in the audience, please feel free to shout if I'm going too much, because I genuinely got interested. It's this idea of, it seems to me at some point, the designer, it's the designer's role, and again, the role of a game designer, I think, is a very, very big subject. And my friend Ty Kelly has a fantastic phrase, which is basically the role of a game designer is to mitigate risk, which sounds very boring, but I think it's a brilliant way of describing it. And if it is mitigating risk, it's not just mitigating risk to the developer, because the way I heard originally when you were talking, it sounded like a very coder mindset, programming mindset kind of approach, but I don't think I was right. I think you've helped me get past that. But it seems that at some point someone has to make calls about things like, well, is it a sword fighting game or is it a shooter game, and what kind of feel do we want for that weapon? Do we want a classical, real world medieval style combat experience, or do we want a swashbuckling Errol Flynn kind of sword fighting experience, or do we want to waggle the thing around like it's a Wii controller kind of thing? And although there's an art component to that, I think it's actually a design decision what those things should be. How does that fit into that model you're describing?
That is true, and that changes nothing from that aspect, meaning the designer isn't in a vacuum. Again, he makes the decisions, but now he makes them in a way that could be easily translated to everyone else, so to speak. Sure. So it's the only purpose of this was because I got bored of writing 1 hour reports every day and reading half an hour reports from my team every day. And I said, okay, can there be something to automate it? And this led to rational game design, which I was also working on at the time. And I thought, why not combine the entire design process from conception to post-production in in one tool, which will eliminate the need for meetings, the need for reports, and most of all, make design reusable, because I was tired throwing away all the design after each game.
I think that's a really interesting point. Anyone got any other thoughts in the last few moments? There's a question over here.
I think it's really interesting because what you're talking about, it almost sounds like an AI matrix, though. Like you could plug in certain parameters of reactions for characters within certain tolerances on these things, and that would, you know, randomize the game or whatever. But you're basically just breaking things down to a really, really low level. So the question I have is, like, when you would use something like that, I think it would make it easy to farm some of that stuff out. Like, if you have or your team even, you say, I need this this element, this character to be within these tolerances or within these with these parameters. This is a boss character. He needs to have this many hits, blah blah blah, or whatever. And
well, yeah, pretty much. If I can just quickly go back. Oh no, out of time. The idea is every parameter is based on 5 theoretical cases, and you can put your personal parameters in between. So when the lead designer or the person with the most experience puts the parameters, everyone else can quickly make it just by sliding. So this is a new character, slide to 1 difficulty. This is a boss, slide this to maximum setting 5. Or it can even make a character impossible for a certain mechanic. An example is from Prince of Persia, Prince of Persia, which was before Sands of Time. There was one enemy which was invulnerable, and it had to be destroyed by getting him to break columns. In this method, you can say, okay, this is so difficult that it's impossible. No matter how much damage you do, this is not what the player has to do. It has to be obvious, so the player does something else. So all of these could be easily manipulated.
And on that note, thank you very much.
So, thanks, guys.